Hello, higher algebra students, here with day 1 of Unit 6, covering graphs and transformations, or functions and transformations. This first lesson here, functions from equations and graphs, we'll jump right into, but one thing to think about with this lesson is this picture right here, and this idea of having some sort of input, some value, or set of variables or variable that goes into a function, and then there's a certain output that would be a value or a function as a result. And so we'll talk about a little bit about what a function is, and a little bit about this function notation that you see right there. All right, so the first thing we're really focused on is whether something is a function or not. And you can see here, a function is a one-to-one relationship between two variables, which means if you have some input x, there is some output y. So this input of the x leads to that y, and there's a certain some rules to follow in terms of that different x's could lead to the same y, but you can't have one x lead to two different y's. And so we'll talk about that, about the idea of you can be loved by many, but you can only love one as we get into the tables here. So here, when you look at this flow chart, you can see this concept of like a would be our x, and f of a would be our y that we're used to seeing, but this is what's called function notation. So f of a just means after we put a into this machine that is producing this function, it produced some result. Same thing here with b. We put b into the function and it produced some result. It's as though it's one of the ingredients in this bigger picture that's going to produce the result here. Now, this is a function here because you can see a leads to the f of a, b leads to the f of b, and x leads to the f of x. Whereas the issue on the right side is going to be this here. A can lead to f of a, but a cannot lead to f of b. Okay, so that x value, in this case a, should really only lead to one of the y values, if you will, after the function is applied, and we'll see that in an example here on the next slide. So as you look at this, and I'll zoom in a little bit, you can see this on the left here. This is considered a function because it is okay if both 2 and 3 lead to the same value. Okay, it just so happens that the machine that you put the 2 and the 3 into churned out the same result. What can't happen is what's on the right side here, which is this idea of the 2 leading to P, but also leading to Q, because if it's put into the same machine, it's not going to lead to two different responses, okay? 2 and 3 could be put into the machine and lead to the same result, but you can't put one value in and have it lead to two different answers. That would not be a function. And so as you look at these options down here, you can see, for instance, in this first one, -1 led to 4, and -1 also led to -6. Okay, so if we were to draw it like you've seen on these others here, -1 leads to 4, but -1 also led to -6, that is a problem. Okay, this would not be a function because you have that -1 that led to two different values. So if you see the same value here on the x side of this table, and that leads to a different result on the y side, that's a problem. Okay, so that would not be a function. Now, the other side of this is on this one, you can see all of the x's are unique, so we don't have to worry about that. But we do have, in this case, that's a little light. We have this 4 here, a 4 here, and a 4 here. So we have the same y in 3 different spots. But again, this is okay because when we put -1 into the machine, it led to a y of 4, okay? When we put 5 into the machine, it also led to a y of 4. When we put 7 into the machine, it also led to a y of 4. But again, it's not the same value leading to two different results. It's just when we put in different inputs, the result of the machine was the same. It's kind of like a video game controller. If you press A, it shouldn't do two different things, or the triangle button or whatever it happens to be. It shouldn't do two different things in the game. If you're trying to jump, it shouldn't make you duck, or vice versa. But there might be up on the joystick or up on the arrow which leads to the same thing. So this could be like up on the joystick, okay? And this could be down here, up on the arrow. You're pushing right there, and they both led you to jump, for instance. So it's okay if 2 different things led to 4. In this case, 3 different things led to 4, but you shouldn't have an x that leads to different things. So this here, yes, this is a function. Okay. Now, graphing provides a little easier way to test or determine if something is a function. There's what's called this vertical line test. And the vertical line test simply says if I draw a vertical line anywhere in my graph, I should never hit the graph twice if it's a function. So as you look at this, you can see this black vertical line here. If I draw it here, if I draw it here, if I draw it here, it's always going to hit that blue graph, that parabola, only once. So that's, yes, that's a function. Okay, but on this side, on the left side over here, if I draw a vertical line here, anywhere on this graph, and again, it doesn't matter where, as long as it happens at once in any spot. If I hit this in 2 different spots, like I did right there, or like I did right here, and so on, then this would not be a function. So it has to pass the vertical line test in order to be a function. Again, vertical line test is just as it sounds. You draw a vertical line anywhere through there, and never would you ever hit the function twice. And so we can see that this one's not a function over here. This one is a function over here. Okay, now evaluating functions using equations. So you've probably spent a lot of time writing these as y equals. And that's still, a lot of times a reader may view these as interchangeable, but really what you're seeing here is what's called function notation. And function notation is something that's really I would say more proper grammar, maybe is the way to put it. That it is clarifying for the reader that the equation that we're putting in here is in fact a function. So what we're doing here is this is telling us what the machine is doing. Okay, so going back to that very first slide, what is the input? Okay, and then what's inside the machine, and then what's the output? So for instance, in this problem right here, 5 is the input. Okay, the machine is the f of x function. So what that simply means is where there was an x, there's now a 5, because as you can see, the x was replaced by a 5. So that's 2 times 5 plus 9, which is 10 plus 9, or 19. So here is your output. Okay, so again, input is the 5, the machine is actually putting it into the function, and the output is your final result. And we could continue doing that here. So looking at the second one, -3 squared. Okay, again, now this is g, right? The input is the -3. Here, I'll change colors to make this a little easier to see. The input's the -3. The machine is this function. So I've got -3 squared minus 4 times -3 plus 1. And again, you do have to be careful here. This -3 is that whole term is squared. So that is actually -3 times -3, which is 9. Okay, the temptation, if you type it in improperly into your calculator, if you type -3 squared into your calculator, this is going to equal -9. But what this one really is -3 in parentheses squared, which is actually -3 times -3. Whereas this one's really like 3 squared, but then a negative in front. So be careful with that. But this one would be 9. Minus 4 times -3, which is minus a -12, or plus 12, plus 1. Okay, so you get an answer there, or an output of 22. All right, and then just really quickly, we'll look at these others here. Here's f again, but of -1, so it's 2 times -1 plus 9, or -2 plus 9, which is 7. Okay, now this next one, 2 times g of 0, what that means is the 2's in front, and then I'm going to put 0 into everything here. So this would be 0 squared minus 4 times 0 plus 1. Okay, so again, the 2 comes at the end. So you could almost do this without the 2 and then just multiply it at the end. I'm just putting it there so we remember. 0 squared is 0. Minus 4 times 0 is 0. Plus 1. So this is really 2 times 1 for an output of 2. And again, that 2 in front, because it's not in the input's still the 0. This is just saying to multiply the output by 2. So when we put 0 into the machine really gave us 1 here. And then we multiplied that 1 by the 2 out in front. So 1 times 2 is 2. This bottom one here, what you're really doing here is just completing both of these functions and then adding them together in the end. So we just would look at it like this. So we've got f of -1, which would be 7. We just found that right there, right? We've got g of -3, which we found to be 22 right up here. Okay, so I won't put you through those again. But then it just says to add them. So we're really just adding here 7 plus 22. So 7 plus 22 is 29, and that would be our output for this entire input and machine here, f of -1 plus g of -3. Again, that was a little easier because we'd already solved each of those individually previously on this slide. All right, moving forward. Composite functions. Okay, so composite functions, what this just really means is we're basically going to put our input through 2 machines. Okay, and the machines actually go in order of which one's closest to the input. So we're going to put it into this machine first, and then the machine that's up front second. Okay, so what that really means is we'll just do an f of 2. Okay, and f of 2 here is 3 and then times 2 minus 1, okay, which is equal to 3 times 1 or 3. But now again, that was just this part. So now what that means is the input for the second machine is this answer. Okay, so now I'm going to do this second f, and it's really f of 3. And why is it f of 3? Well, because f of 2 equaled 3. So we're really just replacing the f of 2 with a 3. Okay. So f of 3 here would be 3, and then in parentheses 3 minus 1, which is 3 times 2 or 6. Okay. So our answer here would be 6 for this composite of functions or composite functions. And again, composite means we're just going with more than one machine in this case. Okay, more than one machine to run these functions over and over. Now again, in this case, it was both the F machine. Now in the next one, you can see we're going to do the G machine first. So we're going to start off with G of -6. So that means that here's our machine. It's the G machine. So we're going to, oh, sorry about that. We're going to use this. So G of -6 is, and then the machine was the absolute value of -6 plus 4. Sorry, that's a vertical line. Because again, I just put -6 into that function. So G of -6 equals the absolute value of -2, which is 2. Okay, what that means again is that this whole thing is 2. So what I'm really solving now is what is the f of 2. Okay, you can see here why we had to do the inside first. Okay, why the g is the first function here is because we've got to figure out ultimately what's going to be the input for f. Okay, and the input for f is determined by the result for the g function here. So we put in f of 2 here, which would be 3 and then 2 minus 1, which is 3 times 1 or 3. Okay, so our final output there is 3 after running it through both functions. Okay, now the last one here, again, we're going to run f of -3 first so we can figure out what's going to go in to the g input. Okay, so f of -3, so that's, again, we're using the f machine now, so that's -3 minus 1, So that's 3 times a negative 4, which is a negative 12. Okay, so that means that this in here is a negative 12. So what we're going to do with this is we're going to take then our g function, the second one, and the g's input then is going to be a negative 12 because that was the result, the output of the f of negative 3 function. So g of negative 12 means we're going to use the g function, but instead of x, we're going to put in negative 12. And it was plus 4, so that's the absolute value of negative 8, which is 8. So that's our ultimate output there. So again, we had 3 different compositions of functions here. And again, we always start with the one that's closest to the input first, because that negative 3, for instance, on this last one, is the input for the function that's right next to it. And then the result of that gives us the input for the other function. And of course, we could keep doing that. We could put 10 functions next to each other and just keep putting them into the input of the next machine to get a new output. All right. Now the last one is to evaluate using a graph. This one's probably the quickest because we don't really have to do calculations so much as to be able to read this graph. So if we assume each one of these boxes is 1 unit, okay, so this would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And obviously there's the 0 or the y-axis there. And then we continue going back, okay? So again, we're inputting the x here. So when we see something like f of 5, like we have right there, that simply means what's the result of our function, which again is what's the y of our function when the x is 5. So again, the input here is the x, okay? So when the x is 5, the result of our function is that it's up about 6 units. So that would mean that the result here would be, the output would be 6, okay? So as we roll through these, f of 7 means, okay, this is our function, okay, so this is f, okay, so I guess that's something to make clear right away that that is our function here. And it is a function, you can see it passes the vertical line test. And I put a 7 into the input, and the result of that 7, when I put 7 into the input, the result is a y value of 3. And that's simply my answer, okay? If I go over to f at negative 2, well, f at negative 2 here looks like, if it's not exact, it's right by 0. You wouldn't be expected to find some crazy decimal there without knowing what the actual equation is here. So we'll assume that that's a y value of 0. You can see at f of 1, the y value is all the way up here. That's actually 8 units above the axis. 1, 2, 3, 4, 5, 6, 7, 8. Now, next one here, we've got f of 7 minus f of 1. Well, simply all we have to do here is figure out, well, f of 7, we already found out was 3. F of 1, we know is 8. So this is just 3 minus 8, because all we're doing is taking the output of f of 7 and then subtracting the output of f of 1. So 3 minus 8 is negative 5. Okay, so it's just, again, you putting it into that f machine and then subtracting the outputs. Again, this bottom one here is 2 times the result of f of 0. Well, f of 0 is what the function is at the actual y-axis, which is at 8. So this is really just 2 times 8, because it's 2 times the result of f of 0. Okay. All right. Some a little more complicated here. I'll just draw in these numbers again quickly. Make it a little easier to find. Okay, so f of 5 here, which is this one right here, goes up 1, 2, 3, 4 units. So f of 5 is 4. F of negative 6, these negatives get to be kind of ugly. But f of negative 6 is right here, which is at a negative 2. So the f of negative 6 led to a negative 2. So this is 4 plus negative 2, which is 4 minus 2, or 2. That answer of 2. So that just shows here what the f of 5 plus f of negative 6 would end up equaling. What does that mean? Not much for us right now. They were actually 6 vertical units apart, but it's because they were added, not subtracted, that we ended up with an answer of 2. Here's another 2 of f of 0. F of 0 here is a 3, so this is really just 2 times 3, or 6. Good, because that 2 up front just gets multiplied by the result. All right, so this is this next one, 3 minus, and then order of operations is going to have us do this division first. So let's see what we've got here. I'll change colors. So we know we've got 3 minus. Let's figure out what that division is going to be. F of negative 2 is right here, and that's a 3. So this is a 3 there. F of 6 is right here, and that's also a 3. So that's a 3. So 3 over 3 is 1. So this is really just 3 minus 1 for a final answer of 2. Seems like it's going to be a lot more complicated than that. But again, we do have to employ order of operations here to remind us that we have to do this division before we can subtract. But again, it was pretty simple for us to just put the inputs into our function. Again, should state that this would be f, and then get the outputs from there. Now this last one, you have to be careful here because the 7 minus 2 actually takes place inside the input, okay? And what that means is that subtraction is actually going to happen first. So this is really f of 5, okay? Because it's not, for instance, f of 7 minus f of 2, that would be a different problem completely. The 7 minus 2 in the input means that's just what we're going to put in the input. So f of 5, 1, 2, 3, 4 units up. So that leads to an output of 4. So just be careful there. If it's in the parentheses like that, the 7 minus 2, then do that first. Okay. Really quickly, composites of functions. Again, we'll consider this to be f. And we just do this similar to how we did it previously. So we're going to worry about the inside f of 3 first. And inside f of 3, here's 3 units to the x equaling 3. We go up 1, 2, 3, 4, 5, 6, 7. So that means that is actually 7. So what we're really finding here is what's f of 7. And f of 7, if we go over 4, 5, 6, 7, this is 7. And from there you go up 2 units. So f of 7 is 2. So that's the composite of functions there, the composition of functions within a function for the graphing. Similar here. And the second one, we're going to find the inside one first, f of negative 1, which is right here. Okay, that's a 3. So this is really f of 3 because the inside, the input of negative 1 leads to a 3 for the output of that first function. And then f of 3, again, we had already found was 1, 2, 3, 4, 5, 6, 7 units up. So that's an answer of 7. So hopefully the composition looks pretty familiar now, both in the equation form and graphing form. The last thing you're going to see is multiple graphs on one coordinate grid or coordinate plane here. So as you can see, the black graph here is the f of x graph. The red graph here is the g of x graph, okay? Now, all you have to do is just make sure you're following the right graph when we get to the right machine or notation here on the right side. So for instance, this first one starts, this is a composition of functions. Again, it starts at g of negative 4. So that means we need the red graph at x equals negative 4. And the red graph at x equals negative 4 has a y value of 2. So that means this is 2. That whole g of negative 4 is 2. So we're going to rewrite this as f of 2 because we just replaced that with what the output of that was, which was 2. So f of 2, now we're in the black graph, okay, because it's the f graph now. So f of 2 is up 3 units, so that leads to an answer of 3, okay? The second one here starts with an f of 9, and that's way over here. F of 9 is actually 0, okay, so that internal function is 0, so we're going to rewrite this as g of 0, and in fact, I'll actually rewrite that in red, since that's going to be the red one. g of 0, and again, that 0 came from the result or the output of f of 9. G of 0, which is the red graph at 0, that goes up 1, 2, 3, 4, 5, 6, 7 units. So that would be 7. Okay? And finally, internal of g of 5. So we've got to go over 1, 2, 3, 4, 5. When x is 5, the y looks to be -1 there. It's actually right at this dot before it starts going back up. Okay? So now I'm going to rewrite, and I should have done this one in black now too, technically. So this would be f of -1, because again, -1 was the output of g of 5. Okay, so f of -1 means I'm going to use the black graph. I'm going to go over to -1 for my x, and that goes up 1, 2, 3 for my y. So I end up right there with an answer of 3. Thank you very much for listening. Hope this helps. As always, please ask questions if you have them. Thank you.